Okay, good afternoon, students of 11P. Right now is already uh, 1 o'clock, and until right now it is already 1:02. Until now, there is no student yet. Okay, I'm start to explaining about the VSEPR theory. Hello, Hayato. Hello, Hayato. Okay, VSEPR theory. Hayato, I hope you already have your uh, what's that the soft copy of your textbook, okay? Because you you need to see the textbook also. After this theory, you have to read your textbook. Okay.
Okay,
VS EPR theory, it is taken from textbook page 60. Okay, VS EPR theory, it stands for valence shell electron pair repulsion. So it is already said here, the stand for is valence shell electron pair repulsion. And we know that based on the abbreviation electron pair, we know that if a pair must consist of two, so there must be two electrons in here. And then valence shell, it means the outermost electron. And then repulsion means there is the repulsion of the electrons in the outermost shell. Okay, now next, and we are studying chapter 14. It is a model used to predict the shapes of a molecule, shape of molecules or molecule. And then electron pairs will repel each other because we know electron carries negative charge. So negative will repel negative. Negative will attract positive. Positive will repel positive. But in VSEPR, there is no positive, it only has negative because it is electrons. And then also this one is it is arrangement that minimize the repulsion. So there is a minimizes of the repulsion. Next, so the arrangement will minimize the repulsion. We have to draw in order to predict the shape using VSEPR. We have to draw dot and cross diagrams, and then we have to do angle measurements. The angle measurement is not able to be drawn using protractor, and we cannot measure the angle using a protractor. Why? Because the angle measured is already definite. It is based on the number of bond pair and number of lone pairs. Okay, so there is a repulsion between the lone pairs. Lone pair and lone pair will repel the most, and then medium, and then the lone pair with bone pair will repel at the medium angle, and then the least angle is between bone pair and bone pair. What is meaning of bone pair? Bone pair is if you draw dot and cross, it is one x, one cross, one cross, one dot. It is called as a bone pair. Lone pair is cross with cross and then also dot with dot. We know that like in structure of ammonia. Ammonia is made up of nitrogen with three hydrogen. So there are three electrons of the nitrogen occupied by the hydrogen, and then there is still a leftover pair. there are two electrons not being used for any bonding. This through these two free electrons, which is not used by the nitrogen, it is called as lone pair. So the repulsion of the lone pair and bond pair is less than the lone pair with lone pairs, because lone pair and lone pair, they have the same charge and they can repel. We know the position like in s orbital. S orbital, there are two electrons in the s orbital. So the between these two electrons and with the p, it will repel the most. Okay, next this one. So the shape VSEPR with no lone pair. It is with no lone pair means there is no lone pair at all. No lone pair at all. So all is bond pair. So all bond pair. There are many bond pairs. There is two, there is three, there is four, there is five, and there is six. And then the two is having angle of 180, and then the shape is linear. And then with three bond pairs, the shape is trigonal planar, and then the angle is 120. So this angle we are not able to measure using protractor. It is already definite, so we have to learn it by heart, or in other words, we have to memorize it. And then for four bond pairs, it is the angle is 109.5. The shape is tetrahedral. So tetrahedral is having like in methane. Methane is CH4. CH4, the four electrons of the carbon is bonded to hydrogen. So bonded to hydrogen, that makes it is become tetrahedral. We know that in tetrahedral there are two structures of covalent bonding, which is simple molecular structure and giant covalent. Giant covalent, like in diamond, is the hardest. Why is it the hardest? Because it has the tetrahedral structure. That makes diamond has high melting and boiling point. It is the melting and boiling point of diamond is different from melting and boiling point in methane. Probably the shape of the methane and also diamond, they are the same. They are tetrahedral structure, but the angle is the same. The difference is the atoms or elements in that build up the methane and also build up the uh, diamond. Okay, and then with five electrons, with five electron with no lone pairs, five electrons and no lone pairs, it has trigonal bipyramidal. Trigonal bipyramidal, it has the angle of 90 and 120. So 90 slash 120, it doesn't mean that it is 90 or 120, but it is n, 90 and 120. And then uh, the last is with six electrons, six bond pair in a structure, in a molecule. It has the shape of octahedral, and then the angle, bond angle is 90. What what is the molecule that having six bond pair and without lone pair? It is the SF6. SF6 is called as sulfur hexafluoride. So sulfur hexafluoride, they have it has the angle of 90 degrees. And then for two bond pairs, the molecule is carbon dioxide. In three bond pairs, the molecule is uh, ethene, is an ethene. And then with four bond pairs, the molecule is methane or alkanes. And then with uh, with five bond pair with zero lone pair, it is PCl5. Okay, so in PCl5, there are two angles, 90 and 120. And then uh, next, this one, VSEPR with one lone pair. VSEPR with one lone pair, there is a molecule or polyatomic ion, which is the name is nitric. It has the bond angle as much as 119, and the shape of the polyatomic ion is bent or V shape. And then this one next, in ammonia NH3. NH3, the bond angle is 107 degrees. The shape is trigonal pyramidal. Why is it like that? Because there is one lone pair and three bond pairs. Okay, and then next, as we move forward, there is four bond pairs and one lone pair. It has the molecular shape seesaw. Seesaw is like the children toy in on the playground that one up, one down, one up, one down. It is the molecule is SF4. Why is it SF4? Because there are six electrons in the outermost of sulfur. Four electrons of the sulfur are occupied by fluorine atoms. So there are two remaining electrons. The two remaining electrons become a pair. This pair is called as a lone pair. And then next, with five bond pairs and one lone pair. Five bond pair and one lone pair, it is square pyramidal. Square pyramidal, the bond angle is 90 degree. The molecule is IF5. Okay, is IF5. Um, so we know that iodine, there are seven electrons in the outermost shell. There are seven electrons in the outermost shell, and then five electrons around iodine are occupied by fluorine. So there are two electrons not making any bond around iodine. This makes one lone pair. Okay, so this one we have to learn it by heart. Next, two lone pairs of the molecule. Two lone pairs with several numbers of bond pairs. There are two there are 3, there is also 4. And then with two lone pair, it is V-shaped or bent. The molecule is water. The angle is 104.5. Okay, the size of the angle, the size of this angle is different from the previous one. The previous also bent with one lone pair, it is bent 119. In here, with two lone pair, the bend is 104. Okay, what does it mean? It means that the repulsion between two lone pairs is greater than between bone pair and lone pair. This measurement, this angle is measured from the angle of the molecule between hydrogen and hydrogen. So there is a repulsion. One OH with one OH, there is an angle 104.5. So the repulsion between two free electrons are very great. That makes the angle of the bonding pairs is very small. Next, three bond pairs with two lone pair. It is the molecule is ICl3, the iodine trichloride. Okay, the shape of the molecule is T-shaped. T-shape is the molecule of a particular molecule is like a T, and then the bond angle is 90. And then in ICl4 negative, it is a square planar. The bond angle is 90. How does square planar look like? Square planar is having like a parallelogram, planar, square, four sides. And then next, the last VSEPR with three lone pairs. With three lone pairs, there is a molecule, there is a polyatomic ion with two bond pair and three lone pairs. It has the shape of linear. Linear always have the same bond angle. It is 190. Get here, linear 190 with no lone pair, and then with three lone pairs, it will form linear also. But the polyatomic ion is different. It is I3 negative. Okay, so in order to tell this one, we have to draw the dot and cross diagrams. Okay, and then now we are on the subtopic electronegativity. Okay, this electronegativity is the ability of an atom to gain electron, so become negative. We know from the periodic table from left to the right, the electronegativity increases. From top to the bottom, the electronegativity decreases. The electropositivity of an atom increases. If electropositive increase means this atom is easy to lose electrons, just like the concept that we learned in chapter 2 about the ionization energy. We know the ionization energy down the group decreases. That makes the atom easy to lose electrons. Okay, so and then example in here is Cl2, Cl and Cl. They have the same. Cl has a certain electronegativity, and then the other Cl has the same electronegativity. So two chlorine atoms combine chemically, they have the same electronegativity. That makes there is no difference in the electronegativity. So we call this molecule to be non-polar. If there is electronegativity, we call this molecule is polar. It occurs with HCl. HCl, the electrons are shared unequally. Unequally meaning there is a electronegativity difference between hydrogen and chlorine. That makes the makes the HCl become polar. And then for ionic bonding, there is a huge electronegativity difference. How come huge? Because sodium loses an electron. That makes the electron move to the chlorine. So the ionic size of sodium is smaller than the ionic size of chloride. That makes there is a inequality of the electrons. This inequality of the electrons, the size is very big. That makes the substance become ionic bonding, and we know ionic bonding is polar. So all ionic bonding and ionic compound will able to dissolve in water. While polar covalent, some of them dissolve in water, but not as fast, not as soluble as ionic compound. And then non-polar covalent, they will not able to dissolve in water. Why? Because water is polar. So polar dissolve in polar, non-polar dissolves in non-polar. Okay, this is about electronegativity. And then about electronegativity, do we need to know the value? In A level, we do not use the value of electronegativity. We need to know the trend of the electronegativity. Example, from left to right, the electronegativity increases. From top to bottom, electronegativity decreases. Okay, this is about electronegativity. And then dipoles of a molecule. This dipole of a molecule, it is the formation of negative side and the positive dipole. The D over here there is a look like D, but it is not D. This is a Latin symbol. The this one we call it as dipole. This is dipole negative. This is dipole positive. Why is it dipole negative? Because oxygen is more electronegative than carbon. Carbon is more to the positive. That makes this one the oxygen is carrying negative. The carbon is carrying positive. Okay, and then because there is a polarity, the polarity increases. That makes this aldehyde to be able to dissolve in water partially. Why dissolve in water partially? Because there is a dipole, there is polarity, but it doesn't have hydrogen bonding. Okay, so we have to look at the tip of the arrow. tip of the arrow negative charge, and then there's a positive charge. That's why it is called as dipole moment, because dipole is the end of the molecule, one end on the right, one end on the left. Okay, next, next, this one, next, overlap orbitals. Last week, in the first ionization energy, we learned already about the s orbital, p orbital, d orbital, and f orbital. Okay, and then the s orbital. How come they overlap? This s orbital, the circle here, represents the movement of an electron. So s orbital contains electron. This also electron. So the electron overlap each other. So they are called as sharing electrons. And then uh, and then this one, the S and P, why is overlapping like this? Because P, we know that we learned already in P orbital, there is Px, Py, and Pz. So there is Px, Py, and Pz. And then the shape of P orbital is a dumbbell or two lobes. So there is an overlapping between p orbital, one lobe of p orbital with overlap with the s orbital. So this is form single bond. And then overlapping also can occur between p orbital and p orbital. So these two, they are called as pi bond. Pi bond. So this one is the double bond. Let's see from this one. This is the last slide. Last slide. So overlap orbitals. This is the p orbitals. This is the single bond. So single bond, there is a overlap between this electron and this electron to form these two. Okay, in the middle, the intersection is the overlapping, and then there is a p orbital, one on top, one at the bottom. It doesn't mean that there are three bonds. It has only two bonds. Why there are two p orbital? Because p orbital, the shape of p orbital is loops, loop on the top and loop at the bottom. So these two lobes will overlap each other. That makes the uh, double bond. Okay, and then next time, maybe tomorrow, we are going to study about the orbital and also hybridization of orbitals. How the carbon can make methane and carbon can make uh, alkene, can make alkene, and also can make into alkyne. Or how come the triple bond forms in nitrogen molecule? Okay, so this is the summary of the chapter, of the subchapter. In order for you to get the main concept, you have to read the textbook. Okay, let me ask to Evo. Hello, Evo. Hello, Evo.
Yes, teacher.
Now, do you have the soft copy of the textbook?
No.
Are you sure? Because last time I already uh, attached on the Google Classroom the link.
Oh. Oh, have.
Yeah. In the first session, I already attached the link to the e-textbook. Okay, so from the e-textbook, you have to read the textbook from page page 60, and then until page 66, page 60 until uh, page 66. Yeah, so from page 60 until page 66 you have to read it. Why? Because this one will give you a clear explanation about the subtopic that I am explaining right now. Okay, before I give question, let me ask to Celine. Hello, Celine.
Yes, teacher.
Celine, I would like to ask you this one. I already explained about the this one VSAPR without lone pair and then with lone pairs. Am I right?
Yes.
Yeah. Okay. Now let me ask you, what is the shape and bond angle of this molecule of the molecule that I am sharing on the screen right now? It is the formaldehyde.
For what formal what, teacher?
What is the bond angle and the shape of the molecule? Bond angle.
Um, Foot angle.
Yeah, bond angle. Bond angle. We have to you have to draw the dot and cross diagram. Cross the Draw dot and cross diagram, and then how can we tell the uh, number of bond pair and number of lone pairs from the central atom? From the central atom here is carbon. So you have to draw how many bond pair and how many lone pair are there in the central of carbon atom. Yes, Celine? Hello, Celine? Draw dot and cross diagram of carbon. So let me do this one, the annotation here. Okay, drawing dot and cross diagram of this one, formaldehyde. So this one carbon, this one XO, here XO, and then oxygen, and there is a O lone pair. This is lone pair. Because oxygen is in group 6, so it has 6 electrons in the outermost shell. And then here there is a hydrogen, and then over here there is a hydrogen as well. So from this diagram, how many lone pairs in the central carbon atom? Celine? Yes, Celine. How many double? How many carbon? How many lone pairs? The carbon atom. Yes, Celine.
Sorry, before my Wi-Fi
Oh
turn
yeah,
off.
yeah.
Hello.
Hello. Yes, Celine.
Okay. Yes.
How many bone pairs and how many lone pairs?
5.
Five. Okay. It is not five. It is four. One, two, and then three, and then there is four. But in according to the VSEPR, according to VSEPR, this formaldehyde is formaldehyde is having only three bone pairs and without any lone pair. How come three bone pairs? Because this one, this double bond, this double bond is occurring between the overlapping of s and p orbitals of the carbon and oxygen. So oxygen here, the s orbital and p orbital of oxygen overlap with the s and p orbitals of the carbon. Well, this one, there is an overlap between the s orbital of hydrogen with p orbital of the carbon, and then also in here there is an overlapping between the s orbital of hydrogen and one orbital or one p orbital of the carbon, because it has three bone pairs and zero lone pair, so the shape of this molecule is trigonal planar. Okay, Celine. Hello, Celine.
Yes.
Okay, now let me ask to Kevin P. Hello, Kevin P.
Yes.
Yeah, Kevin P.
Mm,
Is water polar or non-polar?
polar.
Water is polar. Okay, that's correct. Water is polar.
Yes.
Okay. Um, before the class ends, before the class end, I need to take attendance for grade 11P. Okay, let me take attendance for grade 11P. For grade 11P before class ends. So there is no Alicia, no Alberto, and then there is no Andrew. Billy is also not here. Billy, and then Brian is here. Carlton. Where is Carlton? Carlton was here. I saw his name. Okay. And then Carlton, and then Eiffel is here, Hayato here, Janice here, Kyla here, Kevin P here, Kevin N is not here. And then Mario, I do not see Mario. So Mario, there is no Mario. And then Eiffel is here, Kevin N. There is no Mario, and then there is no Matthew Dharma. Max also not here. Max Million is not here. And then Nia is here. Risky is not here. Risky. Then Saka, I do not see Saka. Sarah, I do not see. Shannon here. And the last Valentino is not here. Does anyone know what happens with Risky? Ata, do you know what happens with Risky? Why is Risky never attending any class? Okay.
Hello, teacher. Teacher
Hello.
Wilodo.
Yes.
Tomorrow, I don't think tomorrow I can come
Uh,
because I need to go somewhere.
okay. Okay. No
Only,
problem. Yes, not problem, Kevin. Okay, no problem, Ata. Because you do not know where Risky is. Okay, so today class is about this one VSEPR. Tomorrow we are going to have exercise on VSEPR. Okay, so good afternoon, students. You may leave the discussion room.
good afternoon. Thank you, teacher.
Yes, good afternoon.
Thank you, teacher.
Yes,
Teacher.
yes, good afternoon. Sharing.